Robbie, when you said Juju on its own, was that Juju like through OpenStack or?
Well, I was just thinking. Oh yeah, well, OpenStack is another thing we should discuss probably. What I was thinking was Juju.
Might increase the font a little bit.
Huh?
We might increase in the font a little bit, I guess.
Is that better?
Yep.
So what I was thinking was Juju. With MAAS working, Juju can deploy to bare metal. So that's one mode of operation. Another mode of operation is Juju without MAAS. So OpenStack is one way of doing that, and the other way is, I guess, in a local environment, because I kind of enabled that last cycle with some.
Through LXC, is it?
Yeah, through LXC.
By the way, for Juju on OpenStack, are you guys? I know you support the EC2 API on top of OpenStack, but are you guys also going to support the native OpenStack API, or will you just use the awesome if OpenStack supports without EC2?
Well, I imagine that if OpenStack works on ARM, then when it works on ARM, then it will support whatever OpenStack supports. So,
but because there's talk of removing EC2 from OpenStack, right?
Yeah, so that would apply to ARM as equally as it would apply to Intel. I don't think there would be any fundamental difference between.
Yeah, I think there's just software and API level, so
yeah, there's nothing special.
Yeah.
The special stuff with OpenStack and LXC is that it is LXC and not KVM. And there are two potential ways to deploy. Do we have a separate OpenStack session for ARM? I think we did.
I think we did already. Yeah.
Have we had it already?
Yeah, I believe so. Wasn't that on Wednesday?
Did I miss it?
I feel like we had that Wednesday.
Sure. I don't know if there was anything special. I think the only.
Yeah, Chuck was going through his list of stuff, right? Of all the.
I didn't participate in it, so I don't know if you had it or just.
Oh, okay. Well, anyway, so with OpenStack on ARM, there are three ways of deploying OpenStack on ARM. One is KVM when we have virtualization support, which is the ideal one, and the other two in kind of meantime things are via LXC and bare metal. So LXC would be like KVM works, except that you would be using LXC instead. So it's really just to look for difference.
Right.
And the bare metal one is that the Nova computer controller would not be running on the bare metal instances that it deploys.
Yeah.
So that's more to do with managing it through system management, or maybe MAAS to deploy this. And then you get the actual machine.
And that's one that we might want to talk about, because it's one of the things probably for Folsom is we will be working on the bare metal backend for our hardware. So the question of how do we want that to behave. So the current bare metal backend for Tyler that the ISI guys have written up, when you deploy it mounts the AMI as an NFS root, and then they boot the nodes with an NFS mounted root partition. The way that I'm thinking of doing it is instead to still use a local disk. So that's what we were talking about yesterday, of having the NetBooter that just goes and does copy images to the local disk. Since you don't have a Nova computer to do that for you, right, like you typically do. So you need something else to come up first, image a disk, and then move back up into that bare metal state.
Would MAAS solve that problem?
Yeah, MAAS would solve that problem. Which is what I was asking the other day, if there was a plan to integrate those two.
I think there was talk of implementing the Nova bare metal compute driver
with the MAAS server, yeah.
Yeah.
So that's something that.
And in terms of DDing, MAAS is a little bit slow at the moment because it has to run DI, but I think there are plans afoot to fix that. Basically, the right place to put DD imaging type stuff in would be MAAS as a faster way of deploying an image.
So because the one question there is if you have AMIs set up and then you want to deploy through MAAS, how would that work? Can you just point MAAS to it and then MAAS will?
Yeah. So currently MAAS does not take AMIs.
Right.
I think if this ever, because people have internally said, let's try and brainstorm ways of speeding it up. I'm not sure if that's going to be in this cycle or not, because I don't remember it being discussed in the MAAS next steps. It's just been like, I don't mean confidentially, it's just, when you chat with a teammate, we just say, yeah, it's a bit slow, we kind of understand it. So I think the MAAS team recognizes that using DI is a little bit slow. So an alternative way of doing it would be to DD, in which case MAAS would have to have some kind of image management. Maybe you could just use Dance.
Yes. Well, I think for the OpenStack case, that's what we
yeah. So I think that part isn't really hammered out at the moment at all.
Okay.
So it's quite open for quite a bit. So if, yeah, I mean, a bare metal OpenStack.
So for the Folsom time frame, then it probably wouldn't be trying to use MAAS and having an dependency there. Probably would not make sense.
I think that's an OpenStack ARM session thing. I don't know if I completely missed that because I remember there being one. I just don't remember seeing it in the schedule.
I think it was Wednesday night.
But I think at least on our side, like if you close the loop all together, like with MAAS, OpenStack, and juju, then we can just, it's a matter of who is going to be dealing with what.
Yeah, I think that makes sense. I think going down the road.
Okay, so can I just get a call for topics? Is there anything from the pad that should be on the pad that's not there for discussion in this session?
I think those are the main topics, at least it seems like. The install mechanism is the kind of the first one, is the principal one, because we don't have any kind of pattern for bootloaders and such. So that's and after that, I think the only thing that is kind of part of dependent is the OpenStack support for like C or KVM. And I don't know if there's any Java dependency around those.
Around what?
Around those components.
Juju uses Zookeeper, which is Java.
But that doesn't have to run your Bootstrap node. Well, I mean, it can.
We'd like our Bootstrap node to be able to run. When I last ran it, it worked, but Java is in a bit of a state of flux at the moment in terms of JVM support. So I couldn't say which JVM I was using. It was the default, and it did work, but it gave me some errors, which we knew, warnings, I should say, which didn't seem to affect the operation last cycle.
I'm just saying it because Java in general is kind of problematic for.
Yeah.
So if you have any dependency on that?
I believe we have Hadoop working, Massimo. We've got Hadoop working, don't we, on ARM?
Yes.
So whatever JVM we're using on that.
Right now we're using OpenJDK, but we're going to be using other JDK cherries.
Yeah.
We have single node and multi-node working.
Yeah. So I'd say that on the whole it kind of looks okay. Maybe we need to shirk out particular bugs in particular applications, but the basic thing works. Performance is a separate issue.
Yeah, I think we should just deal with performance later on. That's supposed to get
just make it work.
Yeah.
Okay, so install images and install mechanisms is something that I wanted to just kind of maybe discuss. There were some questions raised with support for Armada XP, which is in 1204, because people were saying, well, where's the ISO image? And of course you can't do an ISO image, so that doesn't work. So we ended up concluding that the only sensible way to do Armada XP would be to netboot based on the U-boot that we had at the time and what we had about it. Yeah. So currently netinst is the only image we're providing. And then, so the mechanisms are, well, how are we going to go? I mean, so the mechanisms I mean by netboot or USB boot or ISO image or whatever, which is very dependent on the particular system that we're enabling. So
when you say like ISO image, how are you planning to like?
Well, exactly.
Yeah.
So what I'm saying is the possible types of images are netboot, ISO image, maybe USB boot image, maybe some kind of live installer thing. I don't know. You know. So that's what I mean. But obviously, an ISO image makes no sense currently because we don't have any systems that can boot an ISO, and I'm not aware of any ARM servers having CD-ROM drives. So it's kind of awkward.
You're doing SD card images for.
Yeah. So so SD card is another one.
Yeah, at least on the Ubuntu side, the way they're doing is both the live installer and the ISO would be used by the SD card. Like, we're going to treat the SD card as a CD-ROM.
Yeah, except in the server space, the only server board which has an SD card is a Panda board.
That's not a server.
Exactly. It's being, so the Panda board is being managed by the Ubuntu platform team at Canonical, because it's the current standard for the one that everyone has, the one that the community can contribute to, but it's not a real server, and it's the only thing with an SD card. So essentially what I'm saying is, for every single system that we enable, we're going to have to define what that install image, basically we need a different image, whatever form the image might take, for every vendor system that we enable. And for each of those, the install mechanisms that we provide entirely depends on the system and what makes sense at the time. So we're somehow going to be enumerating what these are, so everyone knows what we're publishing. I just wanted everyone to be aware that there is that, and so you can't just go and expect to download the image. It really will depend on the system.
But we do agree that the net installer is most likely going to be a consistent one for each of the vendors.
It does seem that way,
Okay.
yeah.
All right.
And if anyone has any other comments on that, please.
So I have some comments on the net installer.
Okay.
What's that?
Okay, go on. I think now is appropriate.
So one issue I've seen is that to get to it expects to have virtual terminals. So you can get to the syslog, I guess, on a different virtual terminal.
You can get to it. I had the same issue as you until someone told me how. When you get an error, then you can get to it via the serial console. I can't remember how exactly. You just have to poke at it, and you eventually get to the main menu, and you can fire up a web browser where you can access it.
So I've gotten into. So sometimes you can get out to a shell.
Yeah.
When you've preceded it, and sometimes you get into loops where it just keeps telling you the error and retry, and it never gets out unless there's some magic key that's not documented to get out.
I don't believe there is. I think it's either enter or the standard keys that are sometimes you're told about.
But I think those are kind of DI related, isn't it?
Yeah.
And I think we're planning, I don't know, at least Dave said that it might be replacing it with something else or just improving it.
I think the NetInst is going to continue to be DI as far as I'm aware. But I'm not entirely sure about that.
Maybe replacing would be just with the DDEVil.
They're talking about replacing the server ISO with a live install, similar to what desktop are doing. But neither desktop nor server, as far as I'm aware, are ruling out a direct DI. They're just trying to reduce the number of images they support based on what people really use. But the core will always be DI. There's no plan to get rid of that.
Okay.
So as far as I know, that means that the NetInst will remain DI. So that change does not affect ARM because we don't have a server.
Cool.
And for that use case where you get into a loop, that should just be a bug. But
Yeah. Okay, so I would say that the DI situation could be improved in that respect. Please file a bug. It's really a foundations team thing, so it's kind of, there's no one, Adam would be able to help with that, but he's not here. So, but yeah, that could be certainly improved. Thanks.
And I think this is probably going to be like issues that would be related to the other architecture. Right.
What I think maybe a solution would be a pre-seed option to enable SSH early, because you can get an SSH somehow, but it seemed to be non-standard and exclusive to finish an install or something weird like that. There is an SSH in there already.
Yeah.
I don't know how it works.
Yes, you can enable HTTP daemon automatically and netcast in there, so you can access it that way.
But when something fails and you haven't enabled it,
Or if your error is on the networking side.
Okay. What would be good is if there were a particular command at every prompt that you could type.
Or virtual terminals over serial or something.
Yeah.
That's awkward. Okay. So that's install images and install mechanisms. Bootloaders, as I just wrote that down because it seemed to fit.
I think that the usual question and issue that comes with the bootloader. It's not the bootloader itself, but the PXE support that comes with it. Because we are depending a little bit more on. We're just with the NetBoot, we are strictly depending on PXE support and IPMI, but I think that it's kind of related with the board itself, right?
Well, you don't have to have PXE. You can just TFTP load it, the kernel and init RD manually and run it.
Well, still, yeah. Yes. But I mean, now in our idea of case, we would like to make sure that it works properly all the time. So, I think it's pretty hard to tell right now, but it might be that we are missing some features or something that on the current PXE Linux implementation of the Ubuntu.
So what problem are you facing?
No, I don't know if we have a problem.
Oh, okay.
It's just
So
that it's not complete. It's not.
So I had a
back.
brief discussion with Rob about this yesterday. You said that the Naro are quite easy to take fixes.
Yeah.
The PXE Linux emulation in Ubuntu is not perfect, but I think they are happy to take patches to make it better. So if there are any, if there's any parity mismatch between what PXE Linux and Intel can do and what the PXE emulation in Ubuntu can do, please file a bug.
It's mainly just been adding either some options in the menu files that we didn't support that are needed to automatically boot, for example, or interpreting how things work incorrectly.
Okay. Cool.
I'm not speaking for Lenaro.
Yeah, I am.
Oh, you are. Excellent. So the next one is system management. So the interesting thing is that U-boot stuff, like most of us working with these boards, has ended up typing U-boot commands by hand sooner or later quite a lot. I mean, obviously developers would, but also people who are using the boards currently do. I'm hoping that that's going to go away. And I've seen a really good example in Calzetta's IPMI implementation, because as far as I can see, there's now no need. So IPMI is a future. We should no longer have to care eventually about the U-boot implementation details. The only place where it should matter is that DI needs to know about it, and maybe there needs to be a more standard way of how U-boot and DI interact, or if we use EXT Linux as a standard or something else. End users, I think we're now moving to the point where ARM servers are going to all support IPMI. That's what we expect. If you don't support it, you're going to fall behind in terms of MAAS support and everything else. And the official way to change a boot order and stuff like that will be IPMI. And DI, from a user's perspective, should do the right thing. Will detect the system and do the right thing. And maybe that interaction could be improved a little bit, but I think that's an issue for foundations to speak to individual vendors, and I think they maybe it's a bit early to work out those details, but currently DI is capable of detecting the sub-arc and doing the right thing. And so eventually maybe that could go away, but I don't know that's the top of this cycle. Yeah, so that was a system management IPMI bit. So MAAS support. MAAS is planning IPMI support this cycle. With that, things should more or less work. MAAS will need to be sub-arc aware.
When you say the cycle, you're talking 12.04.1 or 12.10?
I think they're talking 12.10, but we might need to push them along to get it done to 12.4.1. They currently use Wake on LAN, which isn't ideal. So
would the IPMI work on that case when we don't have Wake on LAN support?
Okay, so currently MAAS assumes that machines netboot, PXE boot, and is able to power them on. And when it wants to power them off, it does it via inside. And when it wants to power on, it only knows the MAC address of the the node, the first Ethernet on the node, and it will send a wake online packet to that. Currently, MAAS is completely unaware of any BMC. So to add IPMI support, we need to make it BMC aware, maybe management LAN aware, and start sending IPMI commands instead of wake online commands.
Yeah.
So what happens if the machine is hung?
Is
Hung? So that if the
yeah, I
application
think
inside is...
it doesn't. I think it's really the initial thing that it can do correctly, and reprovisioning kind of assumes that it can be shut down. I think.
And how that is done with the consider hardware?
If it's
Do
hung,
you have wake
Can use
online
IPMI.
support or?
We can support that.
Okay.
We generally use IPMI
Yeah.
to power up, power down, reset.
Yeah.
Yeah.
How does MAAS work with systems on different broadcast domains?
I
Is
assume
everything
it
on the
doesn't.
same? Okay.
I don't know. You need a mouse guy, to be honest.
Everything's on one interface. Okay.
But with IPMI support, that restriction will go away. So.
Exactly.
So that's actually quite a lot of work from the MAAS side. I can't speak for the MAAS team, but that's what it needs to be able to do to get this support, which I think is a pretty big requirement for ARM, and I've got a meeting with Davey about that next week, and I'm going to be pushing that. And that's basically my primary goal this cycle, is to make that stuff happen.
Yeah.
So I'm on it, but I can't say where we are right now in terms of the design, unfortunately. So Juju via MAAS should just work. I wrote that down just to separate it from OpenStack LXC Juju stuff. There's nothing. Juju has got a MAAS provider, so it needs a bit of kind of end-to-end testing, and maybe there's going to be some stuff to do with constraints and architecture awareness. Well, Juju has architecture awareness via constraints, and that's it. But in terms of what constraints MAAS can process, maybe there's a few things to do, just a bit of cleanup and stuff, but I can take the action to bite clean for that one. OpenStack and LXC and Juju is a whole separate issue. That is kind of, it's almost out of scope. I think it should be something, I don't know, does anyone have any comments on it?
So what issues do you envision there, right? Because I think, I don't see anything major there either, right? The LXC works with OpenStack, and Juju is just talking over the EC2 API to provision and then deploy. Is there some fundamental gap that you see?
Maybe gap of features, I guess.
Juju should not have any dependencies on whether or not it's LXC or API. I mean, it should just be talking to the EC2 interface. So
If it does, that means there's a gap in the OpenStack LXC, nothing specific to Juju.
right, exactly.
Or ARM. Yeah. I mean, ARM, we've been running Surge's LXC tests on ARM. There were a few issues to do with archive location and stuff. They're all relatively minor. They're all cleaned up now. So as far as we're aware, LXC works just fine on ARM. There's not that much that's going to be different between architectures. So I see no reason why we should hit anything major there.
Do you guys, for anything with Juju, the one thing, do you use volumes at all?
We use what?
Do you use volumes at all? Or do you just use the local ephemeral storage? Deploy on
You mean
EC2?
like for notebook volume?
Yeah. The one thing I noticed with LXC is if you use volumes, it doesn't, so with the general KVM instance, when you debit orders show up, right?
Right.
With LXC, since that's up there, you sort of have to manually go on and then mount it, which depending on what you're doing is not a big deal, but depending on, if your charm if you have a charm that relies on it and it assumes that it's already there,
Okay.
there may be some massaging. But that's just something I noticed. I haven't seen anything break because of it.
I haven't tried OpenStack with LXC, so
Okay.
I'm looking at Al. Yeah, it seems to work. Okay.
And
Send me a note.
Do what?
If you find something broken, yeah, file a bug.
Well, this is, I think it's not broken per se. It's just that it's a limitation of LXC.
Yeah, okay.
Yeah,
I just don't know how many people ever hit that limitation. It's a sort of corner case.
And now talking about KVM, I don't think there's KVM support on the Calzetta hardware, right?
There's no hardware virtualization support on Calzetta hardware.
Unless you modify the spec itself. But On the Linaro side, we're working with the fast models with the A15 to enable KVM. So we don't have hardware, but we have a fast model is like a key email to simulate it and to make it work. So we can at least bootstrap and make sure that it works there on the OpenStack side of it. So that's something that we might be able to help as well.
The KVM is in the pipeline.
Yeah.
Okay. So the next thing I had was requirements for hyperscale. So this is something, I'll put two things down here. Monitoring and discovery. So monitoring was one that Al brought up. Description, discovery. Starts with D. So monitoring is just this issue that we figured that if a node goes down for whatever reason, software error, hardware error, whatever, we need to just consider it as a binary failed node in hyperscale. We don't really want to deal with the details. We just want that node to die, and we want.
You never deployed to it again, you mean?
Huh?
When you say died, is it you never try? You don't try to reprovision on it, or?
Maybe we could try. I don't know.
Because I think it's a bit tricky once you start layering stacks, because you can have an application that causes the node to go down, right?
And then we can redeploy.
Yeah.
It's like a reboot. Yeah. So, but essentially what I'm saying is the failure detection is binary. We don't really care about the issue. We just care that it's gone down.
Yep.
And we probably would only care about aggregate counts of nodes that have gone down or deal with them in groups.
So I think what you need is some sort of state machine that will keep history of it. I mean, so there's a notion of fail and you reprovision. So there's two types of failures, right? One is because there's something the app you're deploying is causing the node to go down, and are you guys using a heartbeat mechanism? How do you detect going down?
This is it. But we were talking about using some kind of watchdog.
Okay, so let's assume you have some sort of heartbeat or watchdog, and it drops, and you say, okay, that node's down.
Yeah.
So you need to be able to differentiate the case of it's because some tenant has an application that causes the system to go down, and you reprovision something else there and it works, versus you notice that over multiple reprovisions that node keeps going down because of a disk.
Yeah.
So that you need some sort of state, kind of a larger timescale state machine to be able to differentiate those two cases. Otherwise,
So
you quickly get to a case where half your clusters.
Yeah. So where would be the right place? I'm thinking MAAS would be the right place for this. From Juju's perspective, so Juju will, if Juju becomes aware that a node goes down, it just starts another one to keep the count of nodes that it should have for a particular service correct. But Juju is a cloud tool. It doesn't care about the instance, right? So it's not in a place to keep that state. And in theory, on the whole, Juju would redeploy to a different physical node from where it was before. So it would make sense for MAAS that to be a feature request to MAAS, I think, to keep that kind of history and manage that side of things.
So it's, I can see it fitting into MAAS. I can also see that in an OpenStack layer you may have a scheduler that's being smart enough to do this. I think it's valid for both to try and do it. I think the tricky part will be if they're both trying to do it, how do they coordinate? Or do you disable it at one layer versus the other?
Well, and I see there's actually two different problems too. One is the Juju OpenStack problem where you're actually trying to maintain information about the status of virtual machines.
Yep.
But then there's the underlying problem of how is my physical infrastructure, right? And those may be the same thing, maybe different things.
I think they are different. I mean, I see Juju it has to do what it does to keep the services up, and it really doesn't care what's underneath. The question of when you have your physical inventory and who's managing what are bad nodes and what needs to go and get serviced, if you have MAAS and OpenStack, who's driving that is a question. Because OpenStack also has its inventory, right? So, because it's valid use cases of just having MAAS and you don't even need OpenStack, right? You just do Juju on top of MAAS and that's it. And their MAAS by de facto has to do this. So I think MAAS has to support doing it. It's just a question of if you have the support in two layers, how do you switch one off? How does that work?
Yeah. Although I think the usual use case would be Juju directly on MAAS will be to deploy OpenStack, and then Juju will speak to OpenStack. I think that's what we expect to happen. Like if we have bare metal deployment on OpenStack, then you'd have MAAS managing everything, OpenStack on a few nodes, and then everyone will talk to OpenStack to go back to the same MAAS to get more nodes, because then we get all the management and networking and image management and everything else.
So MAAS is fundamentally just a way to bootstrap your data center for OpenStack. Is that what you're? That's what it sounds like.
Well, no, because OpenStack would still be using MAAS to provision the other machines.
Depending on the backend.
Or-
It depends on who implements the backend driver, right? So
Yeah.
because of architecture, you can implement your backend driver to take that dependency or not, depending on whether you want.
So,
Because then it becomes it is a bit bizarre. You have a circular dependency, right? Your infrastructure depends on something that depends back on
well,
you.
no, I don't think it's completely secular. MAAS is at the base, managing the physical machines.
Yep.
Juju can deploy to MAAS, or it can deploy to OpenStack. So we decide we can use Juju to deploy OpenStack onto MAAS. Okay, but it will only need 6 nodes or whatever. And then if we're using the bare metal provisioner inside OpenStack, then that could go back to MAAS to deploy more. So it's not quite circular because MAAS is at the fundamental base and it's managing the bare metal. But anyway, so we don't end up with a how is MAAS deployed problem because MAAS is at the base. Anyway, I think the exact arrangement of the stack is going to take time to see what really happens. I don't think we can.
Sure. We're not going to hash it out in this room and say this is how it's going to
Yeah. So I wanted to mention the monitoring at the moment. I don't think there's any current plans to work on that unless someone wants to take it on.
It's in my spare time.
Yeah,
I think
that's how it is at the moment.
it's a fundamental question of how you want to. So going back to that, right? If you're doing a heartbeat or a watchdog, what's doing the heartbeat on the other side?
Well, we talked about a bunch of different possibilities, but I mean, you get some fundamental issues, right? If you have 100,000 nodes sending out heartbeats, that's not going to work.
Well,
Right.
so then it becomes a question of time constants, right? How often do they reach back, and then that means how long will you go before you realize that somebody's down? And
We
that goes
wondered
to
if the
SLAs,
BMC
and it goes up the stack, right?
We wondered if the BMC can help with this because the BMC can manage a heartbeat and go into a failed state.
But then you have to decide what do you consider down?
Which is back to Robert's original statement.
So I said a down is when anything, anywhere signals that it's down, and I said that in software, in user space, that could just be echo 1 into Proxys panic or whatever it is, and that would cause the hardware watchdog driver to stop, and the BMC would know.
IPMI provides a watchdog interface that Linux can use.
Yeah.
Right.
That's it. That's essentially what we were saying. But also what I was saying was any software fault detected should just trigger a kernel panic. Because in hyperscale, we don't care about the details. We just want the node to go down and the BMC to know about it, and the MAAS to know about it, or Juju to know about it.
Yeah, I mean, cool.
Yeah, that shouldn't be a problem today. Well, the problem is, how do we get the BMC once it's detected that failure? What should that do? Because we don't just really want it to reboot.
So either a watchdog timeout or a kernel panic generates a cell event.
Yeah, because the kernel panic will generate a watchdog timeout. And then that fail event, the BMC now knows about the fail event, but what happens from there? How do we get that through to MAAS or to Juju? And that was, again, we've got that polling problem
Well, there's
manifesting itself again.
you can do SNMP traps and stuff.
So SNMP enforced.
I think it can be.
Yeah, well, this is kind of the issue, right? It's just if you've got 100,000 nodes, is 50,000 of them sending SNMP traps unusable?
Well, SNMP traps are losable.
Well, and the other part of the question is that okay?
Yeah.
Right?
Yeah, it might not matter.
It might be okay.
You could just have a Anyway, so currently there's nobody looking at this issue. We're aware of it, but we're focused on basics. So if anyone wants to try and take it on, now is the time to volunteer. Otherwise, it might be a next cycle thing.
Yeah, I'm trying to think it through, but I don't know if we're going to do it next cycle.
So the next topic was discovery, which is kind of related to this. So I would like a great out-of-the-box experience. I'd like someone to buy one of these things, plug it in, and have MAAS know about them all. I don't want to have that user have to start typing IPMI commands to get each one to what's it called? Enrollment? What's that what's called?
Yeah, enroll.
Enlist, yeah. So while enlistment, as it is at the moment in Intel, would also be an option in ARM, I think that in hyperscale, it could be an issue. I want to see additional mechanisms to enlist, which are more practical at hyperscale. So one of the options is that your vendor sends you a list of BMC MAC addresses, and you paste them into a box in a MAAS UI. But even then, MAAS needs to know about the BMC maps, and it also needs to know about the first map of the real system for every node, because that's where a PXE is from, and the BMC is where IPMIs do. So it needs to know both. The most basic way would be to submit that information in a form, and that would be how you do your MAAS enlistment. But I don't think that's ideal. I prefer, while that should be an option, I prefer it to be even more automatic, which means that the MAAS needs to be able to discover the BMC's MAC addresses and a node's first Ethernet MAC address. And I prefer for that to work from the BMC, because that's a trusted management LAN. If we had to work from the node's MAC address, then that's not. So what I understand currently is in the Intel world, or HP world, the way it can be done is once you can get to the agent that's running on the node, you know the node's MAC address because you've discovered the node, and then you can ask the agent on that node that's got this OS already installed forward to examine its own BMC for its BMC MAC address to report that back. But I don't think that's quite secure, so I prefer to see it done the other way. I prefer to see MAAS discover the BMC somehow and then do all the work of the management through the BMC. So I'd like the BMC to be discoverable and a way to query the BMC for the MAC addresses of the node. So how do we discover the BMC? We can poll for it, and that exists in IPMI today. There's an IPMI ping yesterday. But we still have to discover that BMC's IP address. And at hyperscale, we might be using a 10/8 management network. We cannot hold that entire range in a realistic amount of time. So what do we do? That's
Broadcasts, right?
Huh?
Broadcast.
Yeah, so broadcast ping, but we tried that and the BMC can respond currently.
That's probably just a software issue though.
Yeah. So is a broadcast ping on a management LAN sufficient to try and pick? I mean, I guess most of the IPs on a management LAN are going to be BMCs. But there might also be switches and stuff like that. So then we're going to have to poll each of the IPs we do detect to see if it's an IPMI.
You can do a broadcast IPMI ping. So there's an RCMP ping that's specific to IPMI.
And then you'll get them all. Well, if that works, then I think that's a reasonable way of doing it, except for the other catch is that when you've got 16 million machines on your 10/8, your broadcast ping is going to cause congestion on the way back and you're going to miss most of it, right?
Can you do broadcast pings on subsets of that?
But at that scale, you're really just going to have one MAAS server.
Multicast ping.
Yeah, that's the point. I mean, okay, you might not have a single MAAS server. You might end up with, we'll have a MAAS cluster of machines which manage it with failover and everything else. But fundamentally, there will be one agent trying to do the discovery, unless we have separate management LANs or separate subnets.
I don't even know if I would do an HA of MAAS server. You would probably want some hierarchy, right?
Yeah, but whichever way we do it, but are we dividing the management LAN hierarchy or not? Because that's the real question. It's not what the MAAS server is, it's how we've broken down the management LAN.
If you're doing
The
that
trouble
way-
about doing a broadcast is that the broadcast fundamentally goes to layer 2. It's a layer 2 broadcast when you send to a layer 3 broadcast address. And that means that anything on that Ethernet segment is going to receive it, and it's immediately going to try and respond.
If we have
But
issues
I would argue
So
that
that's
you are
when
going to
it's
separate
layer
that,
two
because
congestion.
otherwise you've just given yourself one very large fault domain, right?
Yeah, if you have issues with the ping, you're going to have issues with other things at that scale. The ping's going to be your smallest problem.
It's that all of them are going to be trying to do something at once. Normally, I don't think that's the case. Normally, they're going to be mostly quiet while they're doing their computation or whatever it is they're doing.
When you power on this chassis, right, all the nodes are going to come up.
It's just like when you power on your heavy, big metal hard drive things, we put a delay on the hard drives because we load the power ones. I think it's the same kind of issue here. If we just don't try and get all the 16 million machines to try and identify at the exact same instant, then it wouldn't be an issue.
No, but
they're all coming out to the same pipe, so it's not going to be at the same time. They all have to go through the wire serially.
Yeah, so they're gonna time out on media access,
but
and replying with us.
I still don't buy that you would have 16 million in one. I mean, that's just saying if that one management network goes down, that's it. Pack it in. I mean,
let's worry about that problem when we get to it.
Yeah.
Somebody wants to pay for.
If there's a customer that really
nodes.
has 60 million nodes at the management land, call us.
So, okay, so what I'm saying is we need to work out and agree on a way to discover the BMCs. And I'm concerned that polling or broadcast ping may not be sufficient. I'm not saying we won't support it, we absolutely will support it because it will work today. So we will do it. And
I think the short-term answer is doing that.
Yeah.
So let's see if the broadcast, let's get that working.
Yeah.
And then let's see some numbers, right? Let's see what it looks like.
Yeah, so I will.
We're also talking technical
no problem. You know, that works today, and there's no question. I will get that in MAAS this cycle. That's unless the MAAS team have objections.
The thing is, that should work with other IP vendors too. So
Yeah.
the same way on
Yeah,
C6,
exactly.
no custom community.
Well, what I was thinking was, is that good enough, and should we be considering a better way, a push-based way? Zero conf is the only way I know of, but I'm open to suggestions. But I'm not saying it's a requirement because we will support the basic ping thing and it will work for as long as that stuff works, if you can.
How would zero?
Here's an idea. By default, all the nodes are pixie booting, right? Or booting from network.
Yeah.
So why not just provide a default image that will set up the BMC by DHCP, send information back to the MAAS?
So this is exactly what MAAS on Intel currently does. That's exactly what it does. Each node, if it's not known, will auto exe boot into the MAAS enlistment, which will then make it appear on MAAS. That machine, as soon as it's enlisted, shuts down. Okay, so that will work, but that kind of depends on.
That won't work in a mixed environment.
Yeah, it can work in a mixed environment.
It can.
Yeah, because you just have to give it a different image based on the architecture it's identified as, which it does in the DHCP request. It's awkward, but it can be done.
Well, actually, if you don't put them in the same L2, then you can have your DHCP relay point to different servers as well. So if you have a rack of Calzette and a rack of x86, which you probably would, then you just have your DHCP helpers go to different places.
Yeah, so it can be done that way currently. There's a couple of things about it. One is that currently you have to manually enable stuff, accept stuff in MAAS once it's done it that way because we can't trust the production network. Whereas we could trust the management network more in theory. The other thing is when you first get these things out of the box, are all the nodes supposed to turn on when attempt to netboot? How do you manage which nodes are powered on? Because we control the nodes via IPMI. So it would work if you shipped your hardware with all the nodes configured to power on chassis power on and netboot by default, which could be disk and fail to netboot if you wanted to.
It's configurable, but
yeah,
it would.
But it's slightly awkward, whereas a more robust mechanism would be to do DMC, which is always there. And that would also give people the option to trust it. If they choose to trust the management network, then they don't need to manually enable it.
I think it would be nice if in MAAS that you plug it in and you get all the BMCs come up and then identified, and then you can go hit turn on.
Yeah, that's exactly.
Turn on the machines that you want to turn on.
16 million.
Yeah.
Well, obviously you need ways to do MAAS operations versus single.
Massive web interface. Yeah, there's an API and command line. There will be a command line, so you'll be able to do that. So Ante, what you've said works today, and what I'm asking for is yeah. And that mechanism that exists today will not go away. That will be there too. That will still, I expect, still work. So those are my concerns about hyperscale and the discovery and the monitoring. Someone read that, I can't read it from here.
It is uncommon for a lot of network traffic to take out a BMC even on modern Intel-based systems. Broadcast ping will suffer from that problem, according to Dan. I don't know if the response is broadcast as well, if the response is unicast, but that would make a big difference.
Well, no, I think what Dan's saying is what he has seen is that BMCs will just go down when there's a lot of broadcast traffic.
Well, there should be one broadcast ping and then unicast responses. So, because I'm not seeing how there's a lot of traffic.
Oh, it's not necessarily. It's just
that the responses will attempt to all happen at the same time.
So our BMC is by default set up to towards the IP or DHCP.
Yeah, DHCP.
It's configurable.
Yeah, it is, you know, by default.
Yeah, like Dan says, just some BMCs, this kind of traffic looks like a network storm and they just go away. Yeah.
Well, the thing is, if you talk about broadcast norms, having them all come up and all the BMCs, DHCP broadcast, that's probably the bigger storm than.
But that's only 48.
This is a broadcast ping goes from one source, and you get unicast responses.
Yeah.
Broadcast DHCP is
everybody's going to broadcast, right?
Yeah, but that's only one broadcast, so that's okay.
No, that's how many nodes you have broadcasting. If you've got 16 million nodes, that's 16 million broadcast DHCP requests.
Yeah.
Versus this ping is just a single broadcast ping. So it's nowhere near the size of the networks when we get from DHCP.
Yeah, I'd be more worried about.
Yeah, but only a sensible administrator would only turn on one chassis at a time, and they would stagger the power ons. I mean, just for power reasons, you're not going to try and turn on an entire data center by flicking a switch. That would just be crazy, right? So,
Unless you configure all the nodes to power on when you plug it in. So,
but even though they would put them on power management in any kind of sense.
We're just going to have to wait and see on these kind of things. We're speculating on.
Right.
Because actually, the people who start doing this are not the operations guys who deploy are the ones who flip them on, right?
Yeah.
And then they send you the ticket that says, "Hey, your servers are racked and stacked and powered. Go do what you want to do."
Yeah. So they will flick them on staggered, right? So the DHCP requests broadcasts, they will be staggered. What I'm saying is, if we do a broadcast ping from MAAS, we're basically synchronizing all of them, and that is not something we want to do.
But you get unicast responses, so only the MAAS server sees all that traffic at once. The BMCs don't see it.
Yeah, but the MAAS server doesn't have the capability to receive 16 million packets at the time.
Okay, so when we get 16 million servers.
But again, I would still argue that
even if it's like, we might have a problem at 1,000.
Well, yeah, that's the unknown, right?
you shouldn't hit a problem at 1,000.
You
I'd be very
can flood a box with 1,000. Yeah.
It's the timing. It's not how many there are. It's the timing. We're synchronizing them to the same time point. That's what I'm worried about. That does not normally happen in any other situation.
Again, we're speculating. I think we should get numbers and see what it looks like, right?
Anyway, I've made a point. I'm not saying we need it today. I'm just saying we might want to consider it.
3 minutes left.
Yeah, so that's pretty much it. That's the end of my list.
Yeah, I think.
Does anyone else have any comments?
I think on the other side there's going to be work for the A15 side, but I think it's mostly related with KVM support. And I don't know if there's a lot of coming up during this cycle, but I think once we have it working with the OpenStack, it should be just working fine. And for MVH, I don't think there's anything that's going to be touching this cycle. So.
The only other question I had was IPv6. So I don't know, does you guys DMC deal with IPv6 at all? Or?
It's on the roadmap.
Thanks.
So we've got that 16 million point where we're going to start needing it.
Well, right. Well, I mean, the thing I was thinking about was, at least with that, you play on auto discovery, right? And do something out of configuration stuff like 6, maybe 4, figuring out that that's a BMC file.
I think the discovery is expected to be zero-conf, or more zero-conf orientated in IPv6.
Yeah.
So, as far as I'm aware, the accepted way to do discovery, both in v4 and v6, is zero-conf. But we don't necessarily need it. Okay, so.
It also doesn't necessarily imply IPMI discovery, right? It's just IP.
Well, it's a generic thing for any service.
Oh, okay.
So it might not be in the IPMI spec, but if IPMI has a port number, then
Okay.
zero-conf will allow you to discover it. Or we could use whatever discovery IPMI suggests with the broadcast ping. But the good thing is that zero-conf has got things like fallback. And if you stagger the power, then it's not going to cause a storm, because BMCs will, okay, they'll be batched up in 48, but they won't all try and do it once. And if they fail, then they will eventually make themselves discover all that. They've worked out all the details of the timing and retries.
Okay. There's 1 minute left. I think we're mostly gone. Any other question, concern, topic that we didn't cover? All right. Thank you very much.